Awesome. So, welcome everyone to the Space Education final class. It's been a very great experience with everyone here. From the first class, it shows an introduction to astronomy. The second one was on the solar system. The third one was on space weather, how the sun interacts and affects the planets in the solar system and other things. Then the fourth one was on astrobiology, which was one of the coolest parts for me, at least. Then so now today we're just gonna be a brief recap, and then we're gonna the students are going to share what they've learned, and it's going to be great. So here I have a series of questions that I'll be sharing, and the first one I'm going to copy the link in the chat, and I want you all to go there and drop. So the first question is, what causes aurora? I think we learned that during my own session, which was in the third class, and I talked about aurora and some other things. So I'll just share my screen now. If you have access to the link, so I want to see what answers people are dropping in right now. You can see my screen, right? The right one. What causes aurora? So what causes aurora? Here you see the plus button. Once you open it, you can just add your answers there. I can add my answers here if I want to. Interaction of the solar radiation with the magnetic field of Earth. That is, wow, a very scientific answer. That's my own. Particles of the sun entering the atmosphere. That is very right. So like I mentioned during the class, I was like, the sun, even though it's very beneficial, is always releasing some stuff. Does anyone remember? It's always releasing something called CME, coronal mass ejection, and then it travels all the way from the sun, reaches the magnetic field surrounding the Earth, and somehow it does what? It's able to penetrate. So you can still continue to type, and I'll move on to the next question now. Everybody falls down. That is just the most practical, easy answer. Everybody falls down. So, but is it just people that falls down? What else? We'll be floating around. Very awesome, very perfect answer. So that means there is nothing attaching us to Earth anymore. So everybody is just, perhaps then we can fly. So we don't need wings anymore to fly. I guess so. Buildings will not stay in place anymore. That's also true. Non-existence. The universe as we know it would not exist. That's another level, and I don't even know. So for example, if gravity is broken and perhaps the planets are crashing into each other, and then our solar system might cease to exist. That's true. And in the whole hand, if the same thing happens in other stellar system, then that's a real trouble. So that's really great answer. I really love you guys thought about it. Then I have another question now. There's another answer. There will not be balance on Earth, which leads to floating of everything, including weighty things. Will things actually have weight? That's another question. When there's no gravity, will there still be weight? You can unmute yourself to also answer that. Will there be still? Definitely, stars might not form. That's true. Definitely, stars might not form, because for stars to form, it's a balance between gravity and is it pressure? Pressure is trying to pull them apart, and gravity is trying to bring the molecular clouds into each other. So definitely, there will be no weight. Awesome answer. This is a really great answer. So then we have another question. What how do planet how do plants, so let's assume, so this is an assumption now, so let's assume there are plants on other planets. How do you think they will survive? The link is in the chat. So let's assume there are plants on other planets. How do you think they will survive? Do they need photosynthesis, or what exactly would they need to survive? Remember, there is no perfect right and wrong answer. So this is us just thinking about possibility. It will survive if there's water, if there's protein. Okay, that's good. and starch, okay, they have nutrients in the soil. So there has to be some certain chemical. So that means if you say in the soil, that means there can't be plants in water because you have some planets or in the gas planets, for example, like Jupiter. So that means there can't be plants there. It's not too hot, not too cold. That's right. Perfect temperature. I think that since they are adapted to the environment, they will use the elements gathered in that planet to survive. That is a very good one. And if I'm thinking about it, that means it means like plants in other planets might not be like the plants we have on Earth. So they might not need exactly what our plants on Earth need. They might need something different entirely. Like, for example, in Mars, the atmosphere is with CO2, carbon dioxide. So probably that's all that we need to survive. I don't know. They are able to consume the elements. That's good. Those are really good ones. So we're all doing great, and I'm really enjoying this. Now I have one more interesting question. No, two more actually. Two more interesting questions. I'll drop the link in the chat now. What will happen if there is no sun? What will happen if there is no sun? Yeah, I love that. How can I like this? There's no way to like it. Okay. So let's go to another one. What will happen? I've dropped a new link in this. Will you and I even exist? Very true. There will be no Earth. So if there is no Earth, will other planets exist? Like Mercury, Venus, Jupiter, Mars, Uranus, Neptune, will they exist too? It's only Earth that will not exist. Okay, no, they will not exist. So no, the planets will not exist. Right? I guess that is what this person wants to say. So what else? No planets, they depend on the sun. So what else will we not have? No moon, definitely there won't be moon. So what else? Some things will not be able to survive, which may lead to depopulation. On the planet like humans, they need warm temperature to survive. That is true. So that means the sun is the source of heat. So without the sun is the source of heat. Without the sun, then same thing, the cold. Secondly, other planet used to without like sun may survive. Okay. So if other planets like Neptune may survive, where would they be since there is no sun? And we know that it's the gravitational force from the sun that keeps Neptune rotating, revoluting around the sun. So that means if there's no sun, will Neptune still be able to survive? No human beings, for sure. For sure. Okay, so I think these are great questions. These are great answers already, and I really love it. So now there's one more question. Let's see if we can do a little bit of calculation. So I have this cool thing, and let's see if we can do a little bit of mathematics here. Let's look at this. So I'm just going to do a little bit of reading and I'll explain. We're just going to try to solve one. It's very easy, very, very easy. And so this is an essay that describes solar storm. So the words that belong in the missing blank, they are the one written here. But for you to be able to know which of the words to put in this blank, you have to solve this. You have to solve this thing. So for example, if I solve this and I get plus 20, for example, so that means my answer is comet. Do you guys understand? Do you understand?
Can you explain again, please?
Okay, again. Okay, so we have these essays that have fill in the gaps. So we have 1, 2, 3, 4, 5, 6, like that. So for me to be able to fill in the gap here, that's number one. I have to go to the question here, number one, and try to solve it. So when I solve it, whatsoever number I get, I'll now come to the word bank here. And I look at, so for example, if my answer is 0 from here, so that means the final answer is atmosphere. If you don't understand, don't worry. Let's just go ahead and you'll follow and you understand. So the first, we are just going to try and solve question 1 and question 2, and that will be it. We can do everything. So the first one is, our sun is a very predictable star. Okay. Each day it rises and sets as the world turns upon its axis and warms the earth, making life possible. But the sun is also a stormy star, like we have known about. It produces 1 and incredible explosion of 2 almost every day. So it produces 1. So the first thing to solve is question 1. So what you will solve now is 1 plus 1 minus 3 minus 5 minus 8 plus minus 6 plus 2.
The answer is -2, and that is
What?
flare.
Okay, you solved it already. The answer is -2, and it means flare. Okay. Does anyone have the contrary answer? I want us all to attempt it. So I checked down, and Precious is right. So the answer is -2. So 1 minus 3 is -1 plus 1. Okay, I don't want to go through all that, but the answer is -2. So it means that the sun produces flares, solar flares, and incredible explosions of. So we have number 2 now. So has anyone solved number 2 already?
Is -27. That's energy.
Energy. Okay. So because it's the same person that answered, I believe it's the same voice I heard. I want to hear from someone else. Has anyone attempted it? What answer did you get?
Energy.
Energy. Awesome. Anyone else apart from Precious and Lily? So let's see. So what did I get? The answer is -27. And here we have -27. So from this, we are able to understand that our sun is very predictable. It rises and sets as the world turns upon its axis. It warms the earth, making life possible. But the sun is also a stormy star. It produces what? Produces flares and incredible explosions of energy almost every day. So that is the end of the question session. And can we all give ourselves a set of applause for doing really great? I really enjoyed the answers. Can we give ourselves a round of applause? Let me give myself applause here. So for everyone that participated in Padlet and whichever one, those were really, really great and awesome. And so now we want to go to the student presentation. So this is a very awesome presentation that Precious Kukoyi did. And I want to say that Precious has really been an interactive student from the first class, with giving a lot of answers, and also I don't think he's missed any class, so that is very, very awesome. So the set of questions so we just have 4 slides here. The first one is to talk about what she has learned. Then there were some other questions that she'll be giving us answers to. So let's start from what have you learned? Can you talk to us about what is written here, Precious?
Okay, so I learned that in the universe that it's only Earth that life has been found, but in Mars they say that there are some dry streams that shows that maybe there's some life there, but they moved or they died. So I now learned that our solar system is also made of a very big star, the sun. I didn't really check the how big the sun is. I don't remember. So, and we also have 8 planets. Actually, it was 9 before, but the Pluto gods somehow messed us or so it came a dwarf planet. So, and we have 146 moons, with Jupiter having, sorry, is this that one that has the largest? I don't remember. And a bunch of comets. Then, what is a planet? A planet is a celestial body, or a body that is made up of either stones or gas that forms a somehow circular, not exactly circular shape, and it also moves and orbits around the star. And I want to say the 8 planets. We have Mercury, is the smallest planet, and it moves at a very fast rate. So it's like the closest to all other planets. And some people actually say that it's not the closest because it's like the first and it's far away from others. But like since it moves very fast, it does not stay in one particular spot for like almost 24 hours a day, like the Earth. So it moves and it has distance around the sun. And it's not the hottest. Because of it does not really have something that keeps the heat in. And we have Venus. It is the hottest planet because it has I've forgotten the name. It is the hottest planet, and its distance from the sun is 108.58 million kilometers. Then we have the Earth, which is where life is found, and the distance is 147.87 kilometers. And we have Mars. Is another small planet. Is a small planet, and is a planet that is in the is also a terrestrial planet. So from Mercury to Mars, they are all terrestrial planets. Because of they are made up of some of stones. They have stones like the Earth. So in between Mars and Jupiter, we have the asteroid belts where asteroids are, and some of them come to the Earth's atmosphere, but they burn up, so they are not able to really reach and affect, but some of them are affected. Then we have Jupiter, which is the biggest planet, and the distance to the sun is 740.93 kilometers, million kilometers. I always forget that. Then we have Saturn. Is actually a Jupiter with with the largest rings, and its distance is 1.471 billion kilometers. Then we have the Uranus. Uranus has rings, but it's not really, it's visible, but it's not as big as Saturn. And it has a cold atmosphere, but not as cold as Neptune. And the distance from the sun is 2.9426 billion kilometers. Then we have Neptune. Neptune is in the Greek mythology, we hear that there's a god called Neptune. So I just decided to add it. And it's the coldest because it's the farthest away from the sun. It's not that near to the sun. So the heat from the sun does not really reach it, but it still rotates around the sun. And the distance is 4.4737 billion kilometers. Then from Jupiter to Neptune, we have the gas planet. The gas giant planets. I always forget that planet. So they are made up of gas. They are not made up of stone like other planets because of they are not that near to the sun. So they are not made up of gas. They're not made up of stones. Then, Martina, can you move to the next? Oh, thank you. So there was a question on the WhatsApp that on the group that do sun generate sound, and he said yes, the sun generates sound because as the flares from the sun is coming to Earth, it makes sounds, but it's not. It varies because of the sun is far away from the Earth, so it might be as loud as it is when it is around the sun. Then, can you move to the next slide? Thank you. What are I don't know how to pronounce this thing very well.
Tardigrades.
Okay, tardigrades. They are tiny organisms that survive long, but not that long. They don't really survive all the time too in an extreme condition. So we also saw how tardigrades die. They die from extreme heat. The next slide. Hello, Jesus. Yeah. Oh, this live. Okay, they live for 3 to 4 months. Some of them, they are species. Some of them are 2 years. Some of them are 2 or 4. Anyway, but depending on their dominant states. So, can you move to the next stage? So how do you calculate the sun rotation? It's calculated with sunspots sometimes. It's it said that if you subtract the initial longitude from the final longitude and divide it by the numbers of days in between the observation, it will give you the sun rotation. So now can you hear this one?
That's it. So
Oh, wow, man. I thought it was one there.
do you want to add more? You can add more if you want to add.
I want to add more. I'm coming.
Okay.
Let me find where I kept it. I'm coming. Sorry.
Okay, I'll continue with Lily now, and then we'll come back to the more you have.
Okay,
Is
ma'am.
that all right? Okay. So, Lily, I just got your document, and so I'm not going to share everything that you wrote, but I'm just going to share. I divided it into 4 parts, and yeah, just you don't need to go into all those. I saw that you put a lot of deep science stuff. Just explain the part you understand, and yeah. So, Lily, are you up? Are you ready?
Yes, ma'am.
Okay, that's good. Let's go.
Okay, good day, everybody. Talking about the black hole. As you see in the screen shared, black hole is a region of space-time where gravity is so strong that nothing, I mean nothing, can escape from it, regardless of even particles. So I'm going to talk about this in a very large way. Black holes are seen in rather space, although scientists kind of try to escape this, but it's so strong that even something like 2 miles, 3 miles, 100 kilometers from it can actually drag it close to itself. It's like boundary that nothing can actually very escape it a lot. Although it has a lot of effects, but no one has ever seen anything inside the black hole. And the black hole is formed by the stars that die. Most black holes form from the remnants of a large star that dies in a supernova explosion. Smaller stars become dense neutron stars, which are not massive enough to trap light. As you can see, um, I think black hole moves from one place, and when it moves, it has a kind of attraction that draws things to itself. No one has ever gone through the black hole and comes back to tell the story, if you can understand me. Now, like if someone a particle or something is scattered from the black hole, it forces and veins will spaghettize that thing before it could go inside the black hole, because the effect on that particular thing will be very hard. Map it in next.
That's all.
Okay, thank you. So I'd like to explain about eclipse, solar
Okay.
eclipse. Um, I think our generation has not been able to see this kind of eclipse before, but I've heard about it and I've searched about it, I've learned about it, and this is what I've come up with. So, an eclipse occurs when a planet or a moon passes between two astronomical objects, such as another planet, moon, or the sun. When the moon lines up between the sun and the earth, the moon blocks the sunlight. That's called a solar eclipse. When the earth gets between the sun and moon, it blocks the sunlight to the moon. That's called lunar eclipse. So that means that there's a difference between solar and lunar eclipse. A lunar eclipse can last as long as a few hours, while a solar eclipse lasts only few minutes. And I've learned and heard about it that it can actually blind a person's eye. So according to Nigerians, we place a bucket of water outside the window, then look at the reflection just to see the color of the light. Sometimes it's the sun's turn to shine, and sometimes it's the moon's turn to reflect the sunlight. It's the same as people. So what I'm trying to bring out from this is that this solar eclipse and lunar eclipse, they're difficult to see, and I think it happens in every, let me see, either 40 years. And according to what I heard, I'm not sure, it happened in the 2000 and 2001 area. I hope I've gained from this, although my explanations may not be that understood. But thank you.
That is awesome. That is awesome. You taught us about black hole and about eclipse. Wow, that is awesome. I really enjoyed that. Precious, do you still have something you want to add?
Okay. It's
So
not
you just have
that,
very few minutes, just
and
3 minutes.
it's not really that much. I just want to talk about the the other planets.
Okay.
The sorry, I'm coming. The dwarf planets. We
Okay.
have Pluto, Mary, don't name like that. It's funny.
Mickey, something like that. I don't know how to pronounce it either.
Okay. So now we have the Aries, the Series,
Mhm,
the
mhm.
Meki, and the Umaria. So I want to is it possible for me to ask a question?
Okay.
How did those planets come to being? Those planets, apart from Pluto, the other ones, was it part of our planet before, or they just there like that? I don't know.
Josiah, can you bail me out? Okay, so from my own understanding, I'm sure others we had if I say something. So during the formation of the sun, so the let me say the particles or the matters that didn't form completely form into the sun are what forms into what they call rocks, rocky planets or gas planets. Rocky planets like the Mercury, Earth, Mercury, Venus, Earth, Mars, and the gas planet like Jupiter, Uranus, Neptune. So they are part of the sun. So during the formation of the sun, and so those parts that didn't fully form into the whole body of the sun sort of like break away and then form together, and they began to revolve around the sun because the sun is a large body and has its gravity. So it's like, okay, you guys did not form as part of me, but with my force, I will make you guys rotate around me. So that is my understanding. And so why do we call those one Pluto? Those Plutos and all those one dwarf planet? Because they have to meet some certain conditions apart from their orbit has to be clear. I think that's the main reason why Pluto was eventually called a dwarf planet, because the part where it rotates around the sun is not completely clear. So there are still some other bodies that interferes in those parts. So yes, does anyone want to add anything? Please help me add something. Margaret or Josiah, did I answer that right?
Yes, you did. Was it Precious that asked the question?
Precious, yeah.
Yes. Precious, is that okay? Or do you need another explanation?
Yes, ma. Was okay. Thank you.
Okay, then thank you, Dorcas.
Thank you. Thanks so much, Ma. So Precious, do you have any other thing to add or?
Man, yeah,
question?
that's all.
Okay, that's good. So please, can we all unmute ourselves and give a very good applause to the two people that presented? That was a very, very excellent presentation. I was super impressed. Please, let's clap for them. Precious and Lily, that was really, really awesome. I'm proud of you guys. That was beautiful. So before we move into the next session, where we'll have our two special people and we're going to talk to them. Does anyone have any questions or? Oh, Lily, you have something to say? Okay, go ahead. Quickly.
I just researched why Pluto is not like counted as one of the planets.
Okay.
One, it's smaller than any other planet, even the Earth's moon for that matter. And it's dense and rocky. One of its moons, Charon, is about half Pluto's size. which makes it not that warm and not that cold. So that's what I think is some out of the reasons why Pluto is called dwarf planet. Thank you.
Yes, you're right. Those are very good answers. So there are like a lot of couple of other reasons, and those are part of it. So that's very good. And you know, one of the very good skill about being a scientist is being able to research. And you've become a scientist already. You have a question and you're able to, make research about it, which is very good. I applaud that. So thank you, Lily. That was awesome. And now we have Miss Margaret, Nelly, if you can turn on your camera, and if you cannot, that's fine. But please, can you give us a short introduction about yourself? And Miss Margaret first, then Nelly second. Please give us a short introduction about yourself. Precious, Lily, and everyone, are you guys happy to see them here? Let's clap for them if you're happy to see them here. I'm happy to see them. Yeah. Awesome. Okay, so please give us a short introduction about yourself, then I'll ask you some questions.
Everyone, I hope you can all hear me very well. First of all, I must say very, very good job to the two people that presented today. My mind was blown. I don't think I knew half of what you said at this age, so I'm really impressed. And thanks to Dorcas and Josiah, I guess, for doing a great job. Okay, so my name is Margaret Ikape. I currently live in Canada, in Toronto, and I am an astronomer. For my job, what I do is try to answer one of the questions about the universe that we still don't know the answers yet. And if you remember from the last time that I joined you all, I think 2 weeks ago, I gave a brief introduction of my research, but I'm just going to say it again. So astronomers and scientists believe that the universe started in an event that we call the Big Bang, and the universe was expanding and cooling down all the time from the Big Bang. And before the Big Bang, shortly after the Big Bang, the universe was really hot and really dense. So there was nothing, it was just like a big ball of fire, right? But as the universe was expanding, it was cooling down. And if you take a perfume, a bottle of perfume, and you spray it on your hand, what do you feel? You feel that it's cool, right? Yeah, that's because the gas in the bottle, in the perfume, has been compressed. So it's very dense. And when you spray it, you expand it. So you spray the perfume into the room, the atmosphere, right? That gas comes out and it expands. And when it expands, it cools down. So that is physics, right? So that's the same thing that happened in the universe. As the universe was expanding, it was cooling down, and it cooled up to a point when the temperature was favorable for atoms to form. So hydrogen and helium could form. And this is many years after the Big Bang now. The result of hydrogen and helium forming was that the first stars could now form. So before the sun, there were the very first stars in the universe formed. So my research is trying to understand what led to the formation of these first stars and how they changed the universe. So it's like asking yourself a question: what will the universe look like if we never had those first stars in the first place? So that is my research. I hope that was
really detailed. Thank you so much.
Thank you, ma'am.
Yes.
So Nelly, please introduce yourself, please. Thank you.
Hey everyone, can everybody hear me clearly?
Super clearly.
Yeah, sorry, it's raining very seriously where I am, and it's a bit dark too, so can't put on my camera, but I hope everybody gets to see my lovely face soon.
Yeah.
Okay. So first off, I really like to thank Dorcas for inviting me to attend this class. Wow, it's been really amazing hearing from all of you. Margaret took the words out of my mouth when she said she was impressed, because I am really, really impressed. You guys are so, yeah, you're so articulate. You have grasps a good understanding of the topics that were taught, and I really just have to give you guys all the accolades. Well done, great job. So yes, to give a brief background about myself, my name is Nelly Ebuka. I'm Nigerian and I'm currently in Nigeria. Um, I have a law background in terms of my profession. So I'm from a non-technical field, unlike the scientists and all the space geeks here like Margaret and Dorcas. I cannot really hold a proper conversation on space and astronomy when it comes to the technical aspect, like the distance between Neptune and the sun and things like that. Don't ask me all of that. But that's the interesting thing about the space. There's always a place for everybody. There's always a place for everyone, and that's why I'm really delighted that Doc has invited me here. Okay, so for what I do, I'm just going to capture what I do in 3 thematic focus. So first off, I do a lot of space advocacy. So space advocacy in the sense that I talk a lot about space, in particularly the African space sector and the African space industry, and the benefits of space technology to Africa and how it can help us achieve the Sustainable Development Goals and Agenda 2063, the Africa we want. So I speak a lot in events. I do a lot of space education programs too for children and young people, but majorly that thing is the second aspect of what I do. I do events organizing for in the space sector. So I organize a lot of space events, quizzes, competitions, classes like this, although more physically than virtually. I've just had one virtual space education program that I assisted last year, but most of my space education programs are mostly physical. So yes, I do a lot of that. And then finally, when it comes to space law, would I really call myself a space lawyer? I would say I'm a space law researcher, and then I do a lot of awareness for space law here in Africa. Yes, so my journey so far has been quite interesting, but just to cap off what I do so I don't deviate, this is what I do space advocacy, space awareness, and then space law research and space awareness. Yeah, so it's really nice to be here. Thank you so much, Dorcas.
That's awesome. It's an honor to have you both here. So when did you start developing an interest in the space field? When do you know that this is what you want to do, like you want to do something about space?
So my story is kind of, I don't know. It goes back way back to when I was 6. I remember seeing a shooting star one night, and that was my introduction to the night sky. From then on, I liked to look up in the night sky. I liked to count the stars.
Wow.
You know, like every evening I would stay outside waiting for that first star to come out when it starts getting dark. Yeah, I just liked to look up in the night sky. I used to wonder why the moon was always following when you're walking. That was just my introduction to the night sky. I was 6. I just loved the night sky. I didn't know that was anything. I didn't know anything about astronomy or astronomers, whatever at that time, right? But then when I got to secondary school, I remember my first geography class in SS1, we had, the topic was about the solar system. And the teacher came in, just like Dorcas has been teaching you all. The teacher came in and said so many exciting things about the solar system. And the teacher said the sun was a star. And I got so angry. Like, why would you tell me the sun is a star, you know? Because it's clearly different from the stars I see at night. But that made me like, is it Lily and Precious? Yeah, that made me go to the library and do research on my own. I tried to read so many books, anything I could find about astronomy in the libraries. I just was interested and I wanted to learn more. And it was at some point between SS1 and SS3 that I realized that, oh, not everybody has to be engineers and doctors. Some people can be astronomers, and this is what I want to do. So that's my story.
Awesome. Nelly, please, can we hear from you too?
Just thinking of it now. If only I had the opportunity, Margaret Ikape. That's really awesome. That's awesome. Okay, my story is a bit different. I don't know if I should go way back, or okay, let me just summarize. Okay, so when I was young, I grew up in a suburb, and you know how suburbs are. There's always tales and moonlight. When we all gather in the evening, and then we get to tell stories and things like that. So back in the suburb, there was this crazy story about the moon if you look at the moon, that look very, very, very well. We look at it very well, and you're going to see an old woman with a baby on her back breaking wood, something like that. So I always try my best to like look at the moon really well, so I could finally get to see that woman, right? So that means we did a lot of stargazing actually, like because it was quiet, so it was the star. There was no pollution, so it was always a very good view. Like the stars are always really clear back then. So I think that kind of like sparked my interest in stargazing. But then I went to secondary school and I went into art class. Luckily, geography was compulsory then, so I did a little bit of geography, but nothing substantial. And I just forgot about anything formal education about space. I didn't have any of that. Then I got to the university and I took a course in the university called History and Philosophy of Science. And in History and Philosophy of Science, we had this subject about different aspects of science, and astronomy was one of them. So that kind of like rekindled my love for astronomy again in 2016. But then I was already studying law. So what happened was in my second year, I started doing some researches about space law. I just bumped into space law randomly online. And I was like, wow, this is actually a thing, like laws that govern activities in outer space. This is really a thing, and there are like organizations, there are lawyers dedicated to this, and I fell in love with it. And I just got involved. What really drew me closer to space more was just the fact that I felt very comfortable. This was something I've always liked when I was young, and I don't know, I just felt comfortable because it just made me so happy. Like as I'm here like this evening, I'm really happy. Space excites me, it fascinates me. So that's just how I just got involved. So thank you.
That's beautiful. Thank you so much. So now we know that these people here, they're secondary school students. I'm also a senior. So people here are secondary school students. Can you share what are some of the challenges you actually faced when you were in secondary school that maybe wanted to affect you academically, and how are you able to?
So that is a very interesting question that I probably need to think a bit more. I don't think I had challenges per se. I mean, it depends on what you consider as a challenge, right? I don't think I had challenges per se while in secondary school. And my experience might be different from every other person's, but there were times that like physics and maths and all the classes were really difficult. But I had good teachers that I could go to and ask questions. And I had friends that could also help explain things to me, even in secondary school. we used to have study groups in school. And so we would read together, like we'd come to school very early. I went to a day school. Would come to school very early before assembly and like spend 30 minutes studying, or after school would stay behind just because I didn't want to go home early. I would stay behind and read and study, like solve 1 or 2. It was fun. But it was really helpful. We'll stay behind and like solve mathematics questions. This is mostly leading up to WAEC though. I would solve past questions, physics, maths, and all of that. So I guess that was one of the things that took me through secondary school. Yeah, I'm not sure I'm
That's
asking you
great.
a question, Dorcas, but
Yeah, I actually picked 2 things from there, like you going to your teachers when some things are pretty difficult, and also consulting your colleagues and things like that. So, yep. Nelly, do you have something to add?
Okay, secondary school. I think for me, one major challenge I faced when I was secondary school and generally as a teenager was I did not, and it's completely okay, but I did not really have clarity on what I wanted to do at the time. I actually like joined the arts and took courses like government and literature because everybody said I should, and because I saw that I wasn't really good at physics. So it wasn't because I knew what I wanted to do. So I wouldn't say I started out as someone that had a sense of clarity. So I was really confused and I just like flowed with everything. You're just like, oh, let's just do this, and you just want to do it because you don't know what precisely you want to do. I think that was one of the foremost challenges I had. Yeah. But looking back, I think everything served its purpose. I was able to find myself later on in my late teens, eventually. But it would have been good if I knew what I wanted to do earlier on. Earlier on, I most likely would have done science, most likely, because I'm really inclined to science and tech and things like that. And yes, so I think that's just one of the things I faced.
Yeah, I think in one way or the other, most of us can relate to things like that because when we're much younger, it's harder to, you can't see into the future. So, and I think that's one of the good things why we talk about things like this. Like when we expose them to the beauty of science, probably they'll be like, I think I should go to science. So, yeah, that's awesome. And thanks for saying that. And so the next question is, in your field, can you tell us just one very impactful thing that you think you've done to the field? Maybe, maybe it could be in terms of research or in terms of certain activity, so something impactful that you've done in your area of in your career field.
Okay, I think for me, one major thing I did that I was really proud of, and it's not because I did it, but because I did it despite how difficult it was, because it was pretty difficult at that time, was I represented Africa at the world finals of the Manfred Lack Space Law Moot competition. So a moot competition is like a debate where law students or young lawyers get to argue legal facts. So this moot competition is completely about space. All right. So, and then there's the regionals in Africa, where different universities in Africa will compete, and there are regionals in other continents like Europe, North America, and Europe and Asia and Latin America and things like that, other regions. So I won the regional rounds with my friend. That was in 2019 May, and then we got to represent Africa at the World Finals at NASA headquarters in the United States. So it was one of the most stressful year of my life because number one, it was really academically demanding. We had to solve complex legal problems surrounding space. Don't forget that they don't teach us space law like in Nigeria. Nobody taught me space law. I had to teach myself almost everything, and then my colleague was not as interested in space as I was, so I literally had to teach him everything too for him to catch up. So it was a very difficult experience, and I was really scared because I was going to meet students from Institute of Space Law. We competed with people that were doing their masters in space law, and I was just like a 40-year student that I don't know, hardly knows the left from the right. So it was also a little bit pressurizing because the year before we competed, Africa won the competition for the first time ever. So there was this really high expectations from us, and people get send emails, and it was really difficult. But we came second for the competition, and just that one move or that one act in 2019, it really inspired. It's not about opening the doors, the career doors for me, but inspired so many young space enthusiasts in Nigeria, like so many. Like it was almost like it just opened up this whole door of connecting space enthusiasts in Nigerian universities together. Like a lot of people reached out, and I was able to convene our first virtual youth forum on space in Nigeria with the Nigeria Space Agency. And because, of course, the competition, since we won the competition, I had a little bit of attention, and I was able to utilize it to like convene a lot of space meetings for young people. And I've got to be really wonderful people like Dorcas here since then. So I think I'm really, really proud of that competition because it opened a lot, not just for me, but for the the Nigerian space community in terms of the young people, not the experts. In terms of the young people, we've had a lot of connections since 2019. So I'm really, really proud of that.
Wow. Can I just say that's a story of great resilience, doggedness, and despite that it was hard, you still went all in and you shined and excelled. I'm inspired. For real. Thank you for sharing. Thank you for sharing. So now, because of time, the floor is open to everyone. If you have any question, Precious, Lily, do you have any question for them about career, about pursuing career in the space field, or is there something else we are interested in? And you're like, okay, does this have anything to do with space? And if you don't have question, just give general appreciation to to them because they took time. They're really busy people, and they took time to be here for us today, and we're very grateful for that. So it could just be an appreciation for their presence, and it doesn't have to be a question.
If I want to, if I'm not really interested, it's like this space science is not really my ambition. I'm just like studying it for in case I have a job opportunity and I can like switch courses. Should I be a space lawyer or which one should I do?
A very good and broad question.
Okay, I will ask that question. Sorry, I didn't get to see the name.
Precious.
Okay, Precious. The interesting thing about space is that the industry is so big and wide that it can accommodate almost people with like any interest at all: medicine, law, journalism, business, agriculture, like literally anything. There's a place for everyone in space. And so whatever interest you have, just go to school, keep doing like the normal things that you have to do. If you want to go into like law, that's completely fine. And whatever you want to study, just go into it. It's just that what you have to know is that the industry is wide. So it can always accommodate you despite any field that you want to venture into. When you're ready, just let us know. There are so many space experts in Africa, especially that are ready to mentor people, that are ready to coach people and talk to people. And I'm sure you're going to find your footing. So no need to worry at all.
That's a good answer. Yeah. So whatever it is you enjoy doing right now, keep going. And whenever you think that, okay, I think I want to do more space now, just come to us. So that's good. Do you have any other questions? Okay. So
Question for Precious and Lily.
you have questions for them?
Just one question, yeah.
Oh, that's good.
Yeah. If you don't mind answering me, Precious and Lily, what is your favorite thing about the night sky?
It's the moon. The moon is the favorite thing.
Okay.
Awesome.
Good.
Can I share my favorite part?
Yeah.
Okay, my favorite part is that looking up at night and seeing the stars. Basically looking into the past because I'm seeing the stars and everything as they were years and years ago and not as they are really right now. And it's really amazing to me.
Can you explain that a little bit more? How looking at the star means that you're looking at the past. It's not something we talked about in any of the classes. So maybe you might want to explain it a bit.
Okay, so because light travels at a constant finite speed, it means for the light from the stars to reach us, some time has passed. So that means you are it takes some time before you can see, before the light from the stars reach you. So that means the light you are seeing now has traveled some time. And because the stars are very, very far away, some light might have traveled thousands of years, millions of years before they reach you. That means you are seeing the stars as they are thousands and millions of years ago. Yeah.
Yes. Can I add something quickly? Yes. Okay. Thank you, Josiah. I think that was really great. I heard someone explain this really nicely in Zambia, and I'm just going to steal it because I liked it. So the concept about looking into the past, even to objects as close as the moon, right? When you look at the moon, you're not seeing. So when I look at you, even though we're on Zoom, if I look at your picture, like I can see Dorcas right now. I see Dorcas as she is, like right now, plus or minus a few nanoseconds, right? But but when you look at the moon, you're not seeing the moon as it is right now, just because of what Josiah says. It takes time for that light to travel to you, right? So you're seeing the moon as it was about a second ago. And then when you go further, when you see the sun, you're not seeing the sun right now. You're seeing the sun as it was 8 minutes ago. So if something should happen to the sun right now, like right now, what time is it? 6:24 p.m. You won't know until 8 minutes, right? And the way this person explained it in Zambia that really made me excited was, so I'm currently in Toronto. If I pick up my phone and I call someone in Nigeria, we're going to talk like the person is right in front of me, right? Because these sound waves, which is also like, can also be equivalent to the light waves from these objects, travels really fast. So I speak, the person hears me on the other end, and the person responds, I hear them and I respond. So we can have a conversation. But if someone was on the sun and I wanted to talk to them, when I make a call and I say hello, it's going to take 8 minutes for that person to hear my hello. And then when they reply, it will take another 8 minutes for me to hear their reply. So I thought that was cool. I just wanted to say it.
Yes, that is really awesome. So that means if you're in some particular stars that are really far, it will take how many years? Like 1,000 years. I mean, person is dead already, so you will never even get the message.
Yeah.
Wow, that's a really cool analogy.
But it was very interesting to hear. I think it was Nelly-helen, that analogy about an old woman packing a baby and splitting wood. I just couldn't let that go. All right, so that's fine.
And that is cool. Why? Just a random question. Why do you think we have those things? Does anyone know why it seems like some places are darker on the moon, some places are lighter? Does anyone know the reason why? Or does anyone want to answer?
I don't know, but I'm outside and I looked up to see if I can get a cheat for them. It's out there, there's no.
Can you imagine? Okay. So some places appear darker on the moon, some places appear lighter. And when you look at the overall picture, it's not as if it wants to form a sort of shape. Maybe as if the moon is smiling or something. I think I see more of smile. But yeah, sorry.
If,
Someone, I don't want to give it wrong. Okay, Miss Mary, you want to say something?
yeah, dark spots on the moon are usually called valleys, right? So the moon gets a lot of bombardment from asteroids and meteorites and all of those things going around in space. So when stuff hits the moon, right, they like cause a dent, like a hole on the moon. So I think those dark places are some of the valleys. Like they're very big ones, and I think
Yeah. Those are my thoughts too. I thought they are this thing they call craters. So like maybe one asteroid hits the moon. I think there are really large craters on the moon, and those places are like depressed and they just appear to be darker. Those are my thoughts too. So yeah, so that's pretty much everything now. And once again, huge appreciation to our two special guests. We're happy to have you here, and thank you for answering our questions. Can we all give them a round of applause, please? Thank you so much for coming here. Thank you for honoring an invitation. We are so glad to have you here. One more thing I want to add, or I want to ask. So we are planning towards a future program which should be longer. It can be 3 months, 6 months, or probably even for a year. Would any one of you like to be part of that program?
Yes, please.
Okay, that's awesome. Precious, how about you?
Yes, ma. Yes, ma.
But yeah, there might be some restrictions. So if there's anything, you can reach out to me personally. So you just